Hey friends, this is Miss Bendon. Welcome to your first video of online learning. If you are in my and Miss Mansour's class, you've done sigma notation before, and we're starting out with a review. If you are watching this and you are in Miss Kaufman's class, then this might be newer to you, but that's fine. Your due now to review this topic is Maya gets a job that starts out paying her $30,000 a year. Every year, she gets a 6% raise. How much money will she earn in her second year? And how much money will she earn in her fifth year? I've given you a formula on the slide, and you'll notice that, this is the exponential growth formula because we've got an amount that we're starting with and it's growing by a percentage. So that tells us we're using that exponential growth formula. I've added one thing to it that's different from what you might remember. We've got y equals the initial value times 1 plus the rate raised to the t minus 1. And the reason that we're raising it to the t minus 1 instead of just to the t is that when we have it just to the plain t, we're letting that initial value be at a time of 0. But when we're counting how many years we've worked with at a place, we don't say, all right, we started at year 0. We say we started at year 1. So when you're calculating how much money she's earned in her second year, she's only going to have had her raise once. So you're going to want a 1 as your exponent. So by putting that minus 1, we just sort of correct for the fact that we're counting starting from 1 instead of from 0. If that explanation didn't make sense to you, I'm going to ask you to just take my word for it and use this formula with the t minus 1 as the exponent. Go ahead and pause the video, figure out the answers to these two questions, and then we'll start back up again and we'll do it together. Okay, so there are a couple values that we're plugging in order to use this formula. We're going to need the highlighter. We're going to need to find that initial value, and that's that $30,000 that she starts out getting paid. And then we need that rate, which is 6%. But what do we have to do to that rate before we can plug it into the formula? I'm going to call on an imaginary student over there who told me we need to turn it into a decimal. It can't go in as a percentage. So that 6% we're going to rewrite as 0.06. And then we also need to plug in the time, which for the first question here, how much money will she earn in her second year? We're talking about 2 years. How much money will she earn in her fifth year is going to be 5. So let's just plug it in. That final amount, which we've sometimes called A, because when you're talking about banking specifically, A would be your final amount and P would be your principal, your initial amount. So Y equals 30,000 times 1 plus 0.06 to the 2 minus 1, which I know 2 minus 1 is just 1. And I'm going to go ahead and plug that into my TI-84. And I've got 30,000 times 1 plus 0.06 to the first power. And I get that her second year, she's getting paid $31,800. And then the only thing that's different in the second question is that we're plugging in 5 instead of 2 for the time. So we've got Y equals 30,000 times 1 plus 0.06 to the 5 minus 1. All right, so 5 minus 1 is 4. We've got 30,000 times 1 plus 0.06 to the fourth power. And that gives me that she is now earning $37,874 and 31 cents in her fifth year her job, and it didn't actually come out to 31 cents exactly. If you did this, it came out to 0.3088, but of course I know that money, nobody is going to pay me like half a penny. No, we round money to the closest penny. We round it to the nearest cent, so that means we're going to the nearest hundredth, 2 decimal places over, and 0.3088 is going to round up to 0.31. All right. So that's our do now, and that's sort of a review. We haven't talked about exponential growth in a while. Here's a really similar looking question. Maya gets a job that starts out paying her $30,000 a year. Every year she gets a 6% raise. How much money will she have earned in total after 5 years? And that question, how much money will she have earned in total, is really different from the second part of our do now that said how much money will she earn in her 5th year. Because when we say how much money will she have earned in total after 5 years, we're talking about her first year's salary plus what she earns her 2nd year, plus what she earns her 3rd year, plus what she earns her 4th year, plus what she earns her 5th year. And that's a really different question than the do now, which asked you just what she was going to earn in her 5th year. It's got to have those other 4 years added on. So the shortcut that we're going to use to start calculating things where we have to add up every single term of it is we're going to use sigma notation. And what sigma notation looks like is you get this sigma symbol, which looks sort of like a capital E but messed up. And at the bottom, we put the starting term. So that means the first term that we are going to add up. So if we're doing our do now here, the first term is going to be the amount of money that she earns that first year, and we're going to say that n equals 1 for this particular problem. So I'm going to do my sigma notation and say n equals 1. And then the ending term goes on top, and that's going to be where we stop adding. So we want to go from the first year to the 5th year. So that means we're going to stop adding after the 5th year, and that's what goes on top. And then what goes next to the sigma, and it's going to be in parentheses in your calculator, is going to be the rule that you're using to calculate each piece of this. So the thing that's changing when we go from 1 to 5, that's the year, right? That's the time. But everything else that we're calculating is going to be the same. It's going to be this formula we put together in the do now. It's going to be this 30,000 times 1.06 to the t minus 1, but now we've started calling the time n because we're using n to keep track of first the first year, then the 2nd year, then the 3rd year, then the 4th year, then the 5th year, all the way up. So I'm going to make it n minus 1. And if we plug this into our calculator, just the way we have it here, we will get out the correct answer. Your calculator can give you a different letter as a variable. It can give you that n, but it doesn't have a special variable button for n. When you hit the special variable button on your calculator, what letter do you get? You get x. So that's fine. It doesn't matter what we call our variables as long as we're consistent. So I'm going to change that n to an x. And then what you're going to hit in your calculator is go to the math button, which is just below the green button to the left. That also, you've got math. And then scroll either up or down and get to option 0 that says summation, and it has a little picture of a sigma next to it, and that's the button you're going to use for sigma notation. So hit that button, and you're going to put in the x equals 1. You're going to put it exactly the way you see it on our video right here, 5 on the top, 30,000. And then, so when you put it in your calculator, it already gave you, hold on, I want my highlighter. It already gave you an empty set of parentheses. That empty set of parentheses needs to contain this rule. So if you are going to have additional parentheses inside of that, which you are, you cannot just you cannot move the pink parentheses that they gave you to start with. That initial set needs to have that entire rule inside of it. And I think 90% of the time that students get an error on their calculator, it's because they've somehow put something outside of those parentheses that needed to be inside of it. So just watch that your exponent doesn't end up outside of the parentheses over here. That's not where it should be. It has to be inside the parentheses. So we've got 30,000. I'm opening up a second set of parentheses for the 1.06, and then raising it to the x minus 1. And that variable does need to be written there as an x. So you're putting the x twice. You're putting it under the sigma sign, and then you're putting it again in your exponent. And what'd you get? I got, I did something wrong. Oh, I hit 3,000 instead of 30,000. 30,000 times 1.06 to the x minus 1. There we go. I got $169,112.79. Is that what you guys got? $169,112.79. And again, anytime that we work with money, unless they give us different rounding instructions, we should round to the nearest cent. All right, so that's how we use sigma notation. Let's practice it together 1 or 2 more times. This one's a pretty straightforward one. You're going to try this, put it in your calculator, see what you get out. Again, they give you a k as the variable for this, and we can call variables whatever we want if we're consistent, but the easiest one to put into your computer is the x. So let's replace that k with just an x, and that's fine as long as we replace it in both places and are consistent. All right, well, I got 205. Is that what you guys got? And where that's coming from is, remember that the piece on the bottom of the sigma tells us to start with k at 3 and to end with k at 4, which means that k is going to be 3, 4, 5, 6, 7, 8. And for each of those values of k, we're plugging them in to this rule. So we're doing 3 squared plus 1 is 10, because 3 squared is 9, 4 squared is 16, plus 1 is 17, 5 squared is 25, plus 1 is 26, 6 squared is 36, plus 1 is 37, 7 squared is 49, plus 1 is 50, and 8 squared is 64, plus 1 is 65. And then sigma is putting all of those together and adding them up for you. Excuse me. So when you put this into your calculator, you're doing 10 plus 17 plus 26 plus 37 plus 50 plus 65, which is adding up to 205 total. And that's what sigma does. So one last example. Given the sequence 4, 9, 14, 19, find the sum of the first 20 terms. So my first question for you is this an arithmetic sequence, a geometric sequence, or neither? Great, it's an arithmetic sequence. We are going up by plus 5, plus 5, plus 5. So since we have an arithmetic sequence, we can plug into the arithmetic sequence formula. A sub n equals a sub 1 plus the common difference times n minus 1. And let's pull out those pieces. A sub 1 is our first term, so that's 4. And the common difference is what we're adding. That's that 5. So our formula is a sub n equals 4 plus 5 times n minus 1. All right, but we weren't just asked to find a specific term. We were asked to find the sum of the first 20 terms. So we're gonna, since we're finding a sum, use sigma, and we want to add up the first 20. That means we are starting at 1 and ending at 20. And that's our rule. And that's we're plugging in that 1 through 20 as our term numbers. So we're plugging in that 1 through 20 as the n in our formula. So I'm going to put the rule that we came up with as our sigma rule in parentheses. It's going to be 4 plus 5 times this x minus 1, close parentheses. And if we pop that into our calculator, we get, I got 1030. Is that what you got? We get 1030. I'm just going to write it up here because I am out of space. And that's our answer. All right, so that's your review of sigma. You have a delta math that goes with this. Go give it a try. I hope you guys are all staying safe, staying healthy, doing what you need to take care of yourselves and your families, and also still finding ways to have fun and connect with your friends. Let me know how you're doing. Email if you have any questions, or if you just want to say hi. We miss you. Bye.